Hey guys, Joe back at it once again with some OCR FSMQ past papers, and today we have our final episode, which is going to be the specimen paper. So obviously the quality is a bit, meh, to put it that way. But we'll get into it. It's extra questions, and not long to go till the 2016 exam now. So, question 1, here we go. Express 4x squared plus 8x minus 21 in the form a brackets x plus p, close brackets all squared plus q, and hence find the minimum value. Well, it's completing the square. And the way I like to complete the square here is tease out this 4 first, because we're just focusing on this piece of algebra here. We'll leave the minus 21 alone for a bit. We'll tease out the 4 in that part of maths, and then we're looking like something that we can complete the square with, x squared plus 2x. So what we do there is half the coefficient of x, just like normal, and then we need to take off that unwanted square, which is the minus 1, then times all of that by 4, and you end up with that. 4 brackets x plus 1 all squared minus 25. So you know your a, your p, and your q. Hence find the minimum value of this. Well, we want this bracket to die off, so we're going to let x equal minus 1, and we'll get a minimum value of that minus 25 there. So that is that. Question 2 then, expand 2 plus 3x to the 5 in ascending powers of x, simplifying all of the terms. So it's binomial expansion. We get with lovely columns of mathematics again. We've got with Specimen down here on the left hand side. The person on the left, his power starts high and then it starts to die, it goes to 0. The person on the right, his power starts low and then grows, but remember everything is powered inside that little bracket there. Then you tidy up, and he wants it in ascending powers of x, so therefore you write it in that form. So that's that. Question 3 then, a triangle ABC is such that AB equals 5, BC equals 8, and CA equals 7. Show that one angle is 60 degrees. Well, draw yourself a triangle first, like I have done there. Label the sides like that. And then, trial and error, just try one of the angles. I think I chose this angle here, up top, and then use the cosine rule. So, obviously, the buddies in the scissor, 5 and 8 come first, and then it's minus the 7. Remember they're squared over 2 times 5 times 8, and that, believe it or not, all cancels down to a half. And if you know your trigonometric sort of identities, I guess, if the cos of x is a half, then x must be 60. So that is question 3. Question 4 then. Given that y equals x cubed plus 2x minus 7, find dy by dx. This is a really easy question, actually. Dy by dx, power to the front, not 1 off the power. Quite alarming, that. How early in the paper. How late in the paper that is. That should really be question 1. But then you've got to use your result to show that the graph of that has no turning points. A turning point is another way of saying a stationary point. So we need to set with diff equal to 0, so we get that. Taking people over the other side, you get x squared to be minus 2/3, therefore it's impossible. You can't square root negative numbers at this level of maths, so therefore it must have no turning points. Question 5 then, the line L goes through the points 1, 2 and 7, 6. Find the equation of L. So to name a line we need a gradient and a point. So we've got a point, we need the gradient. So back take back over front take front, which is that, so that's our gradient. And then we'll jump into y minus b equals mx minus a. Put in your numbers. Times through by 3 because I hate fractions. Take people over the other side, you get 3y equal 2x plus 4. Write down the equation of m, the line through the origin, so that's a key word there, origin, which is perpendicular to L. So perpendicular means that it must have a negative reciprocal gradient, therefore it's minus 3/2, and that word origin just means through 0, 0. So we've got our point, we've got our gradient. Y minus b equals mx minus a. The b's and a's don't exist because it's just 0 and 0, so y must equal minus 3 over 2x. Question 6 then. Find the value of the integral between 2 and 1 of x squared plus 3. So that's that. With respect to x, add 1 to the power, divide by the new power. Put your 2 in, put your 1 in, take them off each other. You end up with 16 over 3. Shouldn't say unit squared because it is just a definite integral. But you wouldn't lose a mark if you said unit squared. Just makes you look a bit clumsy. Question 7 then. Rattling through this paper. The London Eye can be considered to be a circular frame of radius 67.5 on the circumference of which are capsules, carrying a number of people around in a circle. Take a coordinate system where O is the base of the circle and OY is the diameter. At any time after starting off around the frame, the capsule will be at a height h meters when it has rotated theta degrees. So draw a graph of h against theta. Now the graph helps you here, so just think of the tilt angle of this line here. So when it starts here, your theta is obviously a 0 and your h is a 0 as well. When it's here, so if I have it there, your theta is going to be 90, and because that's a right angle, and your h is going to be up here somewhere. So we'll write an h there. When it's tilted all the way around to here, your theta is a 180, so that's still increasing, and your h is at its maximum point here, which is up here. As theta comes round to 270, now it's still increasing, but your h is back down to here, so symmetry here. And when it comes back round, theta is obviously 180 when you get to this point here. No, 180, 360, but your h is back to 0, so therefore our graph will look like that. So it peaks, h peaks at the top, but theta keeps increasing till the end of the race. At the end of the race, the end of the cycle. But we'll get rid of that ink now because I'm going to have to explain something about the next question. But nice little graph that for 2 marks. But now we've got a given expression for h in terms of theta. So when this line is there, that is the radius. So that is going to be called r. So if we draw ourselves a little right angle triangle, if we call that r, the hypotenuse, and we say that this, we're going to say this is theta. Yep, that is a theta. Then this line here will be r cos theta. I've drawn this kind of the wrong way because obviously theta's in that corner. I'll take that back a step. In fact, all we need to do is get rid of that there, and that, and that. There we go. So just to talk about that again, so this is an the replica of what's over here. That's obviously a right angle triangle. If we want this height here, that is going to be r cos theta. Cos theta, like that, because soccer tour basically. So that means that the height, which is this, must be this full r, because remember that's r minus your r cos theta. So h will equal r minus r cos theta, which I've probably animated. There you go. And common value of r there, so you tease that to the front and say h equals r brackets 1 minus cos theta, but remember it wants h against theta, so we need to look back into the question and we'll realise that we've been given a value for the r of 67.5 degrees, so we write that, and that is that question. Probably one of the nastiest ones on the paper, but don't worry about it too much if you don't get that. Just watch it over a couple of times and hopefully you'll understand. Now the easiest part of the question, find the values of theta when h equals 100. So simple, we let h equal 100, divide by both sides by 67.5 and you're left with 1 minus cos theta. Switching people over, you get cos theta equal 1 minus 100 over 67.5. So theta must equal 118.8 or 241.2. Now you might be a bit confused as to why you get two values, but that is because, for instance, if we had h up here, like that, it is going to be h at that h twice, because obviously you're going to get a value here and here. So that means there's two values of theta. So next part, simplify to a single fraction the expression that. Well, the easiest way to do these is to squeeze the denominator together and cross multiply. So that's what I've done there. Then expand and you get that. And believe it or not, that is the simplest form that fraction can be in. Hence use the quadratic formula to solve the equation that equals 4. Now the examiner wouldn't have got you to do this first question for nothing, so we can replace this up here with this. So then we're going to set that equal to 4. Times through it by the denominator and you get that. Now expand and you'll get that. Be very, very careful. And then taking people over the other side you get that. And because they've asked you to use the quadratic formula, I'm not even going to bother trying to factorise it. So we'll get that. Putting the numbers into the quadratic formula, which cancels down to x equal to minus 3.257 or minus 0.409. Question 9 then. Show that x minus 2 is a factor of that cubic there. So the way that you show it's a factor is you shove the number through, or you can divide it in and you should get 0 at the end. I just put a 2 through. Obviously you reverse the number that's in the bracket, put that through, and when I did, it did equal 0, therefore it's a factor. And now if I'm solving that equation, I divide me factor into me cubic and I'll get a quadratic on the top, which is x squared minus x plus 6. Probably do that in your own time, just check it out. And then I'll stick them together, factorise. Now I've got three answers of 2, 3 or minus 2. Quite an easy question for number 9 on the page. Question 10 then. Prove that if the sides of a triangle can be written as n squared minus 1, 2n and n squared plus 1, for n is greater than 1, then the triangle is right angled. So if Pythagoras is true, let's draw ourselves a little right angled triangle. The two smallest sides, which is going to be that and that, must add up to get the bigger one. So we would say that, but it's got to be the square, remember. So it'll be the square of that equals 2n squared and n squared minus 1 squared. So that's that. Expanding both sides you get that, but don't tidy up because we'll want to show that the left hand side is equal to the right hand side. So just tidy up the right hand side for now and you end up with that, and they are identical to each other, therefore it is right angled. If you took people over the other side you would have got 0, which is kind of showing the same thing, so that's fine. Question 11 then. The diagram shows a grass bank which was constructed as part of an assault course. The rectangle ABCD is horizontal and ABEF is a square inclined at 20 degrees to the horizontal such that E is vertically above D and F is vertically above C. The area of the square ABFE is 1600 meters squared. X is the point on AB such that AX equals 12 meters. Calculate the area of ABCD. Well, if the area ABFE is 1600, then AE must be 40 because we're told that that is a square. Therefore, its length must equal its width, and them two times together must equal 1600, which is the square root of 1600, which is 40. Therefore, AD equals 40 cos 20, because if we've got AD here, oops, that's awful, AE, this line here, sorry, not this line here is 40. Oh, I've made a mess of this. So the AD is 40 cos 20, which is 37.59. So the area must be 40 times 37.59, which is 1504 meters squared. Now then, the lengths of the paths XE and XF. So XE is this line here that comes down. XF is that line there. So AX equals 12, that there, we're told that in the question. AE equals 40, we'll work that out in the first part. So XE must be the Pythagoras of the two sides that we know, because that is obviously a right angle there. It's really difficult to see over all those lines, but I hope you get the idea. And once you Pythagoras them up, you get 41.76. Similarly, BX equals 28, and you're thinking, how did you get that? Well, the whole thing is 40, and we know that that there is 12, so therefore this line here must be 28. BF is 40, so Pythagorasing them up, you get 48.83. Now, we want the angle between the paths XE and XF. Well, that is this angle here. And we know this line up here is going to be 40. So this is a cosine job. So we do that. Angles in a scissor, square them up, minus the opposite side, and over two lots of the sides in the scissor. And you get that. Shift cos that, and you get 51.7 degrees. Part D then, the angle of the slope between the path XE with the horizontal. So XE is obviously that, and the horizontal is this, I believe. I think it's that, or it might. We'll see anyway. So ED in this case. Let's just erase all the ink off the slide. So I'll turn my pen off. ED is 40 sin 20. That line there. And sin x equals 40 sin 20 over 41.76, which is this line here. And remember, the angle we're looking for is that one there, I think. If you can imagine it, it's very difficult to do 3D. So sin x equals that, shifts in that, and you get 19.1 degrees. Question 12 then. A body has fallen through a liquid, and the distance fallen is modelled by the formula S equals 48t minus t cubed until it comes to rest, where S centimetres is the distance fallen and t seconds is the time. So find the velocity when t equals 1. Well, the relationship between displacement and velocity is through differentiation. So we get v equals 48 minus 3t squared. Once we bring power to the front, knock 1 off the power, and all that. And we want the velocity when t equals 1, so we shove a 1 through, and we get 45 centimetres. Now the initial velocity means when the clock equals 0, so that means when t equals 0, therefore we'll let that t equals 0, therefore v's are 48. And now we want the acceleration when t equals 1. So the relationship between velocity and acceleration is through differentiation. So power to the front, knock 1 off the power, we get that. When t equals 1, a equals a minus 6. And remember, all the units for this are centimetres per second or centimetres per second squared, because it's centimetres against seconds. The time when the body comes to rest, well, that's when v equals 0. So we'll set with v function equal to that. C common factor 3, divide through, and you get that. Taking people over the other side, you get t squared equals 16. Therefore t is a 4. Could be a minus 4 as well, but since we're talking from t equals 0 onwards, we're only interested in 4. And now we want the distance fallen when the body comes to rest, so we'll put the 4 through a displacement function, and we get that, which is 128 centimetres. And now we want to sketch a velocity time graph for the period of time until the body comes to rest. So that is that there. And that's because obviously when initial velocity is 48, our final velocity is 0, and it takes 4 seconds to get there, and it's a negative x squared graph. So that's why we do that. Question 13 then, the easiest binomial distribution question ever on OCR FSMQ. It's a lovely, lovely question. China cups are packed in boxes of 10. It's known that 1 in 8 are cracked. Find the probability that in a box of 10 chosen at random, no cups are cracked. Well, first of all, x can be binomially distributed 10, an eighth. We want the p of x equals 0. That is 10c0 times success to the 0 times failure to the rest, which is that. P equals 1, very similar. It's going to be 10c1, success to the 1, failure to the rest, which is that. And for p of x equals 2, 10c2 times success to the 2, failure to the rest, and you get that. And the last bit, at least 3 cups are cracked. Well, p of x is greater than or equal to 3 is the same as 1 minus the p of x is less than or equal to 2. So 2 less than or equal to 2 means 2, 1 and 0, and we've worked them out in A, B and C, so we'll shove them through and we'll get that, which is that. And job done. You got yourself 12 marks for not much work if you know your binomials. Question 14 then. Our linear programming question. A bicycle factory produces 2 models of bicycle A and B. Model A requires 20 hours of unskilled and 10 hours of skilled labour. Model B requires 15 hours of unskilled and 25 hours of skilled. The factory employs 10 unskilled and 8 skilled labourers, each of whom work a 40-hour week. Suppose the factory makes X models of A and Y models of B per week. Show that the restriction of unskilled labour results in the equality 4x plus 3y is less than 80. Well, 20x plus 15y must be less than 400 because I've got 20, 15, and then remember it's 10 unskilled workers, but for a 40-hour week, so times them up. That's a common factor of 5 there, so I divide through by 5 and I get 4x plus 3y is less than or equal to 80. And we've also got to find a similar inequality from the restriction on skilled labour. So we'll do the same thing. It'll be 10, add 25, and then 8 times 40, which is 320. That's a common factor of 5 again, so I divide through and I get 2x plus 5y is less than or equal to 64. Now I've got to draw graphs of the 2 lines and shade the feasible region, which is that. So it's obviously all this area here that's been shaded out up here like that. So another 3 marks there. The factory makes a profit of 40 on model A and 60 on model B, so that means 40x plus 60y is p, which is our objective function, and show that making 15 model A and 5 model B bicycles is possible, and find the number of each that should be provided. So you get your objective function, you let it equal a friendly number, you draw it on, I think it looks something like that, and then you go as far out as you can in the white zone, and you'll realise that you don't get an integer solution, so you have to fiddle around with the numbers, go up, go one down, make sure they work with the inequalities, and it turns out that the biggest profit is actually 14 and 7, but just do that through trial and error once you've got your values. If you don't understand integer solutions, go and check out part 3 of linear programming on the channel. There's lessons for everything. And that is the end of the specimen paper and the end of our past papers sort of little series. So I hope you guys have found it helpful. Please leave a like if you did. Obviously it'll tell me that I'm doing an okay job. Leave your feedback down below. And yeah, good luck for your FSMQ. I will try and get a PowerPoint of the actual exam up, so probably not on the same night of the exam, but maybe at the weekend or something like that. So after you've sat your FSMQ on the Monday, hopefully by the weekend I'll have had my model answers put onto the PowerPoint, and we'll see. I mean, obviously there's no guarantees I'm right, but it might, reassure some of you guys. But you'll be absolutely fine. Work hard, make sure you know what you're doing, plenty of practice, and you'll do great. So yeah, I hope you guys have found the lessons helpful, the past papers helpful, and yeah, thanks for watching everybody, and goodbye.